Our project is called CoRobotics, Workforce Development in the Age of Intelligent Robots. I'm Caroline Campfield, and my partner is Clay Pretty. Our faculty advisors on the project are Dr. A and Ali Buendia, and our project was funded in part by the Kentucky NSF EBSCOR grant.
So what is a cobot? That is the real question right now. A cobot is a collaborative robot that works with people. These robots are meant to take on monotonous tasks that people necessarily don't have to perform. It isn't really taking a person's job, rather taking a job that a person doesn't have to do all the time and which could cause injury to them. Collaborative robots are designed specifically to work alongside a person, so they don't have to be in a cage like a regular robot, and they're governed by regulation and safety standards that control the velocity, the weight, and the type of objects that the robot can be holding in order to protect the person from harm.
The overall goal for our project is to help prepare the workforce in Kentucky to embrace this new technology. Other top universities in the United States have been doing research on collaborative robots, and we are hoping to bring this field of research to Western. Our project is part of a larger collaborative robotics lab that will be in the Center for Energy Systems here at Western. This will allow our project to be used for research and education once we are finished with it. Additionally, our project is part of the NSF EBSCOR grant, and we are partnered with several other universities in Kentucky and united under the same goal of preparing the future workforce of Kentucky to use this new technology in the manufacturing industry.
The approach for this semester was a three-way path that were all parallel to each other. We wanted to do simulation, research, and robotic selection and purchase. This semester, with the current pandemic that is occurring, we have had to delay the purchase of the robot, and therefore we'll push it back to our next semester part of our project. We have completed all of our simulation and research up until this point, and in next semester we will be developing perception as well as developing educational modules to teach the future workforce of Kentucky.
One of the steps in our process was to select a robot, and to do so we used a decision matrix. Here we compared several different companies of robots as well as some basic criteria. And from this analysis, we determined that the Sawyer and Universal robots ranked the highest, but since they were tied, we needed to do some more analysis in order to determine which one was better suited for our needs.
Yeah, and taking upon a further analysis of the two, we talked to the companies that make the robots and found that Sawyer had more torque sensors, which will allow us to collect more data to help students better understand what is happening with the robot, as well as help with research in the future for different types of co-robotics. Therefore, we went with the Sawyer robot for our purchasing.
We next looked at the different simulation softwares available to use for our robot. There are a few company-owned softwares as seen on the left of the screen, as well as some independently owned softwares as seen on the right. We decided to use the Gazebo simulation software as it is free, open source, and we've had some experience in the lab working with it. There are two phases to our project. Phase 1 took place this semester and consisted of research and simulation. In the research portion of this phase, we determined what exactly a collaborative robot is, what applications exist, the different safety standards that govern a collaborative robot, as well as looked at the different research being done in the field. From this, we determined that collaborative robots are the future of the manufacturing, health, and agricultural industries. Moving on to the simulation part of this phase, we decided to use the robot operating system ROS in the software Gazebo. The first simulation that we did was with the TurtleBot. Here we followed pre-made tutorials to lead the robot through basic manipulation and object detection. We then moved on to use the Sawyer simulation, where we were able to control the robot through keyboard commands as well as through waypoints.
Yeah, and moving on to phase 2, We plan on next semester working to develop a robotic perception. A robotic perception is the ability for the robot to understand its environment, the objects that are in its environment, as well as itself in the environment. It would be able to identify what an object is based upon the shape of the object and to take action accordingly to what the object was. As if it was a person, the robot would not go near it it would not go near the object in order to cause harm to the object. We've already started working on this, however, as we've been able to take a raw image footage and turn it into canny edge detection. This will allow us to send it through an image processing program that will allow us to identify an object based upon the edges that have been processed through our edge detection. This has already been done, as you can see on the left-hand image, through a university called Berkeley. Berkeley took a regular robot and had a 3-depth camera to where they could identify a person as well as objects such as the boxes in the image. The functional flow block diagrams that we plan on using are going to be used to help the user or student to understand what is happening with the robot. As we can see on the left, the simulation flow diagram is used to help the user understand how the code is stepping through and what actions the actual robot is doing in this code. And on the right, we can look at how the robot's basic task is. This is really helpful in understanding how the robot's going to interact with objects or people in its environment.
Additionally, there are a few technical aspects to our project, one of which is how the simulation software actually moves the robot. This is called inverse kinematics, and here the user would input where they want the robot to go, and then using this concept, the software determines the angles each joint on the robot needs to move in order to get to that location.
Yes, and it's like we said in phase 2, object detection is a big portion of our project. As you can see on the right-hand image, the person is taking a raw image footage and they're using edges to detect what the objects actually are and identifying by the little green squares where the object is in its location. We plan on using this in our future to where the robot can detect objects and interact with those objects based upon its identifying what it is.
Moving on to some of the simulations we performed, the first was manipulating the robot through keyboard commands. Here you can see on the left of the screen, the user is inputting the different keyboard strokes, and on the right, the robot is responding to those.
And on the second simulation video, we can actually see that the robot is doing waypoints. Waypoints are a known location that the robot needs to go. And as we can see, when the robot picked up the cube, it knew where the cube was as it was identifying that waypoint, picking up the cube and moving it to its secondary location. The secondary location, however, the cube has changed its angle at which it was sitting, and the robot cannot actually pick up the cube in its second attempt. This can be improved, however, if we had added object detection and perception into it to where it would identify that the cube has changed its position and it would have acted accordingly to pick up the cube. What's next for us? As we had discussed before, object detection is a huge thing that we need to take under. We plan on taking the previous semesters that have worked on this, such as their object detection programs and allowing our edge detection that we've already done and identifying what those objects actually are. But with the coronavirus pandemic that is occurring right now, we are having issues with actually obtaining a real robot. Therefore, simulations are going to be our primary use of working with the robot. This is not a problem, however, as the simulations are grounded in physics. And similarly, we will also have to be working on the floor plan and implementation of our robot next semester as well. Thank you.